The final formula that we take a look at is called the rate of return approach. And in this one, we're not interested in finding the present value. We're actually interested in finding the interest rates that is going to cause the entire project or investment to break even. So as before, let's go ahead and break down each of these components and do an example so you guys know exactly what to do. Here we have the rate of return approach. Rate of return approach. And there's a different name for the rate of return approach. We can also call it the marginal efficiency of capital, the internal rate of return, the IRR. Once again, that's going to be something that you see in your finance classes a lot. So here we'll just write that down. Marginal efficiency of capital, also known as the internal rate of return. Internal rate of return. Rate of return. So the dreaded IRR. So let's go ahead and find out what we need to do with the rate of return approach. Essentially, what we want to do is find the interest rate when the present value is equal to 0. Find the interest rate when PV is equal to 0. And when we find the interest rate when the present value is equal to 0, that's where the investment breaks even. So where investment breaks even. And we're going to use the same components as we did with the previous formulas. We have the present value on the left-hand side. Here we have the summation of the future value for n time periods, 1 plus I raised to the n. And then we're going to subtract out the new component, which is going to be the cost of the investment initially. And in terms of the rate of return approach, it becomes very, very difficult as we include more and more time periods. So if we have year 1, year 2, year 3, this entire formula essentially becomes a geometric and arithmetic series, essentially because of the denominator right here, it's being raised to the n time periods. So algebraically, it's going to become very, very difficult to do by hand. It'd be a lot easier if you had a graphic calculator or a financial calculator where you just go ahead and insert these numbers in and the number will pop out. Here we'll stay simplistic and only take a look at the rate of return approach from 1 year to the next year, just for simplistic purposes. You'll get into the more complex versions once again in your finance classes. So let's go ahead and take a look at an example of this. So suppose you find a 1967 Pontiac GTO, so good old-fashioned muscle car for sale. And it's going to be for sale at $20K, so $20,000. And you expect this $20,000 car to be worth $25,000 in 1 year. And you expect it to be worth $25,000 in 1 year. The question that we want to ask is, what is the interest rate, or what is the rate of return? Rate of return that will allow you to break even. That will allow you to break even. And once again, we just go ahead and use this formula right here. So what numbers do we have? Do we have a present value? Remember that with the rate of return approach, our present value is going to equal to 0. So we just go ahead and put that on the left-hand side automatically. We're not interested in finding the present value. We're interested in finding the interest rate right here. Next, we go ahead and add in, do we have a future value? We have a future value of $25,000. That's exactly what we expect the car to be worth 1 year from now. So $25,000 goes on top. We have 1 plus the interest rate. Remember, the I is our unknown. And the time period is 1 because we're just going from 1 year to the next year. And then we want to go ahead and subtract out the cost. The initial cost is $20,000. So $20,000 if we pay for this car right now. And then this becomes a simple algebraic problem. We do a little bit of manipulation, going from left-hand side to right-hand side and trying to isolate the I by itself. So let's go ahead and do this step by step. If you sort of need the steps right here, we bring the 20,000 over to the left-hand side. We add both sides. So 20,000 here, we're left with 25,000, 1 plus I. And then we want to get rid of the denominator right here. So we're going to multiply both sides by 1 plus I. So we're 20,000 times 1 plus I is equal to $25,000 right here. And then we go ahead and distribute the $20,000 on both sides. We have 20,000 plus 20,000i equals to 25,000. And then now we can go ahead and simplify this a lot more. So here we keep on going. We have 20,000 plus 20,000i equals to 25,000. We take the $20,000 on the left hand onto the right hand side. We have 20,000i. 20,000i. We have 20,000 equals to 5,000 right here. So just subtracting the 20,000, and then we divide through by 20,000 just to isolate the I. So I equals to 5,000 divided by 20,000, and then that'll give us a percentage or a decimal of 0.25, which equals to 25%. So here, the interest rate that's going to allow us to break even on this project, on this investment, is 25%. And what exactly do we do with this rate of return or this interest rate? Well, typically, most firms and most businesses have some sort of standard rate of return that they need for every single project. So if a firm or you yourself say, hey, I have a baseline or a benchmark of 10% rate of return on all my investments, would you want to go ahead and buy this car right now? And the answer would be yes, because it gives you a return of 25%, and that far exceeds your own 10% benchmark. But what happens if you're a little bit more stringent on your rate of return? Suppose that you have a rate of return benchmark of 35%. Then would you go ahead and make this investment? And that answer would be no, because it doesn't match up with your threshold or your benchmark. 25% is less than 35%. So essentially, this is what the rate of return approach is going to do, and is exactly what we are interested in solving for, this interest rate and not necessarily the present value. So 4 different formulas for finance using the time differentiation that we talked about. We have the annuity, we have the single income flow with the present value, we have the future income flow with the present value, and we finally have the rate of return approach. So take a look at all these 4 formulas, see how they are similar, see how they're different, and you'll be good to go with a lot of practice.